Hello friends, now we will start the new exercise 5.3. I will explain all the theoretical part, all short examples and all examples from the exercise 5.3. Now let us start. Now let's learn product of vectors. We can find product of vector in two ways. When the result of product is a scalar, the product is called scalar, or it is called the dot product. And if the result is a vector, it is called vector, or it is called the cross product. Now next is a scalar product of two vectors. It's a definition. Let A bar and B bar are two vectors in the space which is inclined at an angle theta. We define the scalar product, or it is called the dot product, of these vectors as A bar dot B bar is equals to AB cos theta, where A, B are magnitudes of A bar and B bar respectively. Now their properties. Properties of scalar product. You are learning in 11th standard in physics. A and B are the magnitudes of the vectors A bar and B bar. Hence, A bar is greater than or equals to 0 and A is greater than or equals to 0 and B is greater than or equals to 0. If theta is the acute angle, then cos theta is a positive. In this case, A bar and the B bar are non-zero vectors. Then AB cos theta is a positive real number. If theta is obtuse angle, cos of theta is negative. In this case, A bar and the B bar are non-zero vectors, and then AB cos theta is negative real number. If theta is a right angle, then cos of theta is 0, because cos 90 is 0. And in this case, if A bar and the B bar again non-zero vectors, then AB cos theta and that's equals to 0. From this result, it is clear that if the scalar product of two non-zero vectors is 0, then they are perpendicular to each other. Next is B bar dot A bar is equals to BA cos theta and that's equals to AB cos theta, and that is nothing but A bar dot B bar. It's clear that thus the scalar product is commutative. Next property. If A bar and the B bar are perpendicular or orthogonal, then theta is equals to 90 degree. A bar dot B bar is equals to AB cos of 90. But what is the cos 90? 0. And overall you will get the 0. Conversely, if that A bar dot B bar is equals to 0, it gives that AB cos theta is equals to 0. Therefore, A bar is equals to 0 or B bar is equals to 0, or A bar and the B bar are perpendicular to each other. Next point. If A bar and the B bar are parallel, then theta is equals to 0. Then A bar dot B bar is equals to AB cos of 0. But what is the cos 0? Cos 0 is 1. 1 into AB and that's equals to AB. In particular, that is the A bar dot A bar, that is the same vector, the dot product of the same vector with itself. The angle between them is 0. That A bar dot A bar is equals to A into A cos of 0, and cos 0 is 1, and then A into A is A square, and hence in particular A bar dot A bar that's equals to A square. A square can be written as, that is a mod of A bar bracket square. If A is a unit vector, and then mod of A bar is equals to A and that's equals to 1. Therefore, A bar dot A bar is equals to 1, where A bar is a unit vector. Next, consider the basic vectors I cap, J cap, K cap. They are unit vector and are mutually perpendicular as they are along OX, OY, OZ. I cap dot I cap, J cap dot J cap, K cap dot K cap, and that's equals to 1. Next is, if we take, that is a I cap dot J cap, the angle between them is 90. And that's why, that's again j cap dot I cap, that's equals to 0. J cap dot k cap, again the angle between them is 90 and cos 90 is 0. And therefore their dot product is 0. That is a k cap dot j cap, that is equals to 0. And also k cap dot I cap, that is equals to I cap dot k cap, and that's equals to 0. Now the expression for a bar dot b bar in terms of I, j, k. Now see this expression for a bar dot b bar in terms of I cap, j cap, k cap. Let a bar is equals to a1 I cap plus a2 j cap plus a3 k cap, and b bar is equals to b1 I cap plus b2 j cap plus b3 k cap be any two vectors. Then a bar dot b bar is equals to in bracket a1 I cap plus a2 j cap plus a3 k cap dot in next bracket b1 I cap plus b2 j cap plus b3 k cap. Now their dot product. Here we take the first term a1 I cap will multiply all these three terms. Then what you will get? a1 b1 I cap dot I cap. Next is a1 b2 I cap dot j cap. Next is a1 b3 I cap dot k cap. And similarly for the others also, a2 j cap will multiply to this whole bracket. And then you will get a2 b1 j cap dot I cap, a2 b2 j cap dot j cap, and the last is a2 b3 bracket complete j cap dot k cap. Again a3 k cap will multiply to this all the terms in this bracket. Then you will get a3 b1 bracket complete k cap dot I cap plus a3 b2 bracket complete k cap dot I cap plus a3 b3 k cap dot k cap. Now here I dot I cap dot I cap, and that is 1. But the j cap I cap dot j cap, that will become 0. I cap dot k cap, again it will be 0. J cap dot I cap, it will be 0. And j cap dot j cap, and that will be the 1. Which term will be there now? That is a1 b1 plus a2 b2, and the last is a3 b3. And that's why a bar dot b bar is equals to a1 b1 plus a2 b2 plus a3 b3, and hence we have that is a bar dot b bar is equals to a1 b1 plus a2 b2 plus a3 b3. Finding the angle between the two vectors. Let a bar is equals to a1 I cap plus a2 j cap plus a3 k cap, and b bar is equals to b1 I cap plus b2 j cap plus b3 k cap be the two vectors. And if theta is the angle between them, then a bar dot b bar is equals to ab cos theta, and that's why cos theta is equals to a bar dot b bar upon ab. But what is a bar dot b bar? A bar dot b bar is nothing but a1 b1 plus a2 b2 plus a3 b3. And what about their magnitudes? The magnitude of a is in root of a1 square plus a2 square plus a3 square into in root of b1 square plus b2 square plus b3 square. If the vectors are perpendicular to each other, then theta is equals to 90. That is the cos theta is equals to 0, and that's why a1 b1 plus a2 b2 plus a3 b3, that's equals to 0. Projections. Let a bar and b bar be two vectors represented by OA bar and OB bar respectively, such that theta is the angle between them. Vector projection of b bar on a bar, vector projection of b bar on a bar is equals to OC bar, and that's equals to mod of OC bar dot a cap, where a cap is a unit vector along a bar, and that's equals to in bracket a bar dot b bar upon a into a cap, and that is nothing but a bar dot b bar upon mod of a bar, it's a magnitude. And what about this unit vector? That is a vector upon its magnitude, that is a bar upon mod of a bar. Projection of b bar on a bar, again that's equals to a bar dot b bar upon a into a cap, and that is nothing but a bar dot b bar upon mod of a bar into a bar upon mod of a bar. Projection of a bar on b bar, that's equals to a bar dot b bar upon b into b cap, and that is a bar dot b bar upon mod of b bar into b bar upon mod of b bar. Now the next is very important topics: direction angles, direction cosines, and the direction ratios. Direction angles. Consider a line L in the space. This is the line L in the space. Let OP be the directed line parallel to this our line L, capital L. Clearly, the angles made by the line L and ray OP with the positive directions of the coordinate axis are the same. That is, this line L and the OP makes the same angles with the coordinate axis. The angles made by a line with the positive direction of x, y, z axis are called the direction angles. And that is the first angle with the x-axis, that is the alpha, with the y-axis is beta, and with z-axis is the gamma. Then the alpha beta are known as the direction angles of that line L also. Now the direction cosines. If alpha, beta, gamma are the direction angles made by a line capital L, then the cosine of these angles, that is cos alpha, cos beta, cos gamma, are called the direction cosines of the line OP. They are denoted by L, M, N. L is equals to cos alpha, M is equals to cos beta, N is equals to cos gamma. The direction cosines of the x, y, z axis are: for the x-axis, that is the angle with the x-axis is 0, and with the y and z they are 90, 90. Therefore cos alpha, cos of 0, cos 0 is 1, and next is the angle made by with the x-axis to the y is a 90, and also z is a 90. Cos 90 is 0, therefore the direction cosines of x-axis is 1, 0, 0, and similarly for the y-axis. Again the y-axis will make an angle of 90 degree with the x-axis. Therefore alpha is equals to 90 there. An angle with the y-axis itself of its y-axis is a 0, and cos of 0 is 1, beta is 0 there. Similarly with the z-axis it is a 90, and also here the direction cosines of the z-axis are 0, 0, 1 respectively, and hence you have to remember this. The direction cosines of x, y, z axis are 1, 0, 0, 0, 1, 0, and 0, 0, 1 respectively. If alpha, beta are the direction angles of a vector OL bar, then the OL dash will be, this is the OL dash. If the alpha is the angle made by that line L with the inner direction, positive direction of the x-axis, and then pi minus alpha is the OL dash. Similarly for the pi minus beta with the y-axis and the pi minus gamma with the z-axis. And therefore here cos alpha, cos beta, cos gamma and OL dash are. What about the cos of pi minus alpha? Is minus cos alpha. Cos of pi minus beta is a minus cos beta, and cos of pi minus gamma is a minus cos gamma. And therefore the direction cosines of the lines are plus or minus L, plus or minus M, plus or minus N. Now the remark: if alpha, beta, gamma are the direction angles of a line, and the values of these alpha, beta, gamma always lies between 0 to pi. A directed line has a unique direction cosines. Parallel lines have the same direction cosines. Now the relation between the direction cosine of a line. The direction cosines are LMN. Is there any relation? Yes, there is a relation. What is that theorem? If LMN are the direction cosines of a line, then L square plus M square plus N square, and that's equals to 1. Let AB be a line with the direction cosines LMN. Consider a line L passing through the origin and parallel to the line AB. Okay, consider the line AB and again parallel to this OL. Let P, X, Y, Z be a point on the line L. This is the point on that line L. That is the length OP is equals to R. Okay. The position vector of the point P is OP bar is equals to xi cap plus yj cap plus zk cap. And if alpha, beta, gamma are the direction angles of the line OP, then the L is equals to cos alpha, M is equals to cos beta, N is equals to cos gamma. And therefore, next is OP bar dot I cap. That is, what is OP? OP is xi cap plus yj cap plus zk cap, bracket complete I cap, and that's equals to x. Now here I cap dot I cap, that is 1, I cap dot j cap, that is 0, I cap dot k cap, and that's also 0, and overall their product is x. Next is OP bar dot I cap, and that's equals to the product of. We will apply here the definition of the dot product, that is the product of their magnitude and cosine of the angle between them. Therefore, OP bar dot I cap, that is equals to their magnitude, that is the mod of OP bar dot angle between them, that is the cos alpha, and OP bar is equals to R, and therefore OP bar dot I cap, that is equals to R cos alpha, and also we have the value of OP bar dot I cap, that is also x. Therefore this x is equals to R cos alpha, and hence we get x is equals to R cos alpha. Similarly, we have y is equals to R cos beta, z is equals to R cos gamma. Now here OP bar is equals to R cos alpha I cap plus R cos beta j cap plus R cos gamma k cap. Now OP bar dot OP bar, the product of these two vectors to itself, that is R cos alpha I cap plus R cos beta j cap plus R cos gamma k cap. In second bracket, R cos alpha I cap plus R cos beta j cap plus R cos gamma k cap, and their dot product, that is I cap dot I cap. Then you will get R square, R cos alpha bracket square, plus R cos beta bracket square, plus R cos gamma bracket square, and that's equals to R square cos square alpha, R square cos square beta, R square cos square gamma, and take R square as a common. R square get cancelled on both sides, that is OP mod of OP bar square is a R square. Here R square get cancelled, and then you will get cos square alpha plus cos square beta plus cos square gamma, and that's equals to 1. But what is the cos alpha? Cos alpha is L, therefore L square, cos beta is M square, and cos gamma is N, therefore L square plus M square plus N square, and that's equals to 1. And in this way, we have proved the relation between the direction cosines of the lines, which is a L square plus M square plus N square, and that's equals to 1. Now the direction ratios. A real numbers proportional to the direction cosines of a line are called the direction ratios of that line. That is, if L, M, N are the direction cosine of a line, and if A, B, C are real numbers such that A upon L is equals to B upon N is equals to C upon N, that's equals to lambda, a constant. Okay, lambda is a constant. Then A, B, C are called the direction ratios of that line. For example, 1 by root 3 minus 1 by root 3 and 1 by root 3 are the direction cosines of a line. Then its direction ratios are 1, minus 1 and 1, 1, minus 1 and 1, or 1, minus 1 and the minus 1 if you change the sign. Or you can multiply this, all these 1, 1, minus 1, 1 and this 1 minus 1, 1 by the 2, by lambda, etc. That is, any non-zero constant multiple of the direction cosines of a line are the direction ratios of that line. Thus, a line has infinitely many direction ratios, but unique direction cosines. Now the next, relation between direction ratios and the direction cosines. Let ABC be the direction ratios of the line, having their cosines are L, M, N. Then L upon A is equals to M upon B is equals to N upon C, and that's equals to lambda. As L upon A is equals to lambda, then L is equals to lambda A. M upon B is equals to lambda, that is M is equals to lambda B. N upon C is equals to lambda, that is N is equals to lambda C. Next is L square plus M square plus N square, that's equals to 1. Substitute the value of M that is a lambda into a bracket square. Means what? Lambda square a square. Value of the m, lambda b, lambda square b square. Value of the n, lambda square c square, and that's equals to 1. Take lambda square as a common, then in bracket a square plus b square plus c square, and that's equals to 1. And therefore lambda square is equals to 1 upon a square plus b square plus c square. Take the square root on both sides. Then you will get lambda is equals to plus or minus 1 upon in root of a square plus b square plus c square. And hence you have, that is a L is equals to plus or minus a upon in root of a square plus b square plus c square. M is equals to plus or minus b upon in root of a square plus b square plus c square. N is equals to plus or minus c upon in root of a square plus b square plus c square. For example, if the direction ratios of a line are minus 1, 2, 3, then the direction cosines are, that is a minus 1 upon in root of minus 1 square plus 2 square plus 3 square, 2 upon in root of minus 1 square plus 2 square plus 3 square, 3 upon in root of minus 1 square plus 2 square plus 3 square, and hence minus 1 square is a 1, 2 square is a 4, 3 square is a 9, 9 plus 4, 13 plus 1, 14, and hence we get the direction ratios are minus 1 upon root of 14, 2 upon root of 14, and 3 upon root of 14. And now we see these are the remark. What is the remark? Let P x y z be a point in the space such that OP bar is equals to R bar, and the line OP has the direction cosines L M N. Then x is equals to LR, y is equals to MR, z is equals to NR. That is a P. That point will be LR plus MR plus NR. I think that here is a NR. Okay. Here is a NR. Also R bar is equals to mod of R bar in bracket Li cap plus Mj cap plus Nk cap. R cap is equals to, therefore R cap is equals to Li cap plus Mj cap plus Nk cap, where R cap is a unit vector along the line OP bar. Next is a, if R bar is equals to AI cap plus Bj cap plus Ck cap is a vector having the direction cosines L and N, then ABC are the direction ratios of R. L is equals to A upon mod of R bar, M is equals to B upon mod of R bar, N is equals to C upon mod of R bar. Okay. The direction ratios of the line passing through the 2 points, we can find out it. Suppose that the point on that line is x1, y1, z1, and the another point is x2, y2, z2. Then what are their direction ratios? That is the difference of their x coordinate, y coordinate, and z coordinate. That is x2 minus x1, y2 minus y1, and z2 minus z1. Okay. Parallel lines have proportional direction ratios and the same direction cosines. Now the next topic is the angle between the two lines. The angle between two lines is defined as the angle between two vectors parallel to the lines. Theorem: the acute angle theta between the lines with the direction cosines L1, M1, N1 and L2, M2, N2 is given by that the cos of theta is equals to in mod of L1, L2 plus M1, M2 plus N1, N2. Let A bar, B bar be the two vectors with the direction cosines L1, M1, N1 and L2, M2, N2 respectively, if the theta is the acute angle between them. And let E1 cap and E2 cap be the unit vector along the vectors A bar and B bar. Thus the E1 cap is equals to L1 I cap plus M1 J cap plus N1 K cap. What about the E2 cap? That is the L2 I cap plus M2 J cap plus N2 K cap. They are dot products. That is E1 I cap dot E2 I cap. Now here is the definition of the dot product. What is the definition of the dot product? Product of this dot product is defined as product of their magnitude. What is the magnitude of E1 I cap? E1 cap is 1, E2 cap is 1, and cosine of the angle between them, that is the cos theta. Similarly to the right hand side, their dot product, that is L1 into L2, M1 into M2, N1 into N2. The other terms will be absent there because I cap dot j cap, I cap dot k cap, and all the remaining, that will be the 0 because they are perpendicular and cos of 90 is 0. Therefore, here we treat only the L1 L2 plus M1 M2 plus N1 N2. As here 1 dot 1 is 1. 1 into cos theta is cos theta, and that's why cos of theta is equals to in mod of L1 L2 plus M1 M2 plus N1 N2, as the theta is the acute angle. Now the important remarks. If A1 B1 C1 and A2 B2 C2 are the directional ratios of two vectors A bar and B bar. What about the A bar? A bar is a A1 I cap plus B1 J cap plus C1 K cap. And B bar is a A2 I cap plus B2 J cap plus C2 K cap. Let theta be the acute angle between the vectors A bar and B bar. What is A bar dot B bar? A bar dot B bar is a mod of A bar dot mod of B bar into cos of theta. That's the definition of the dot product. And that is equals to, again, what is the A1 into A2 plus B1 into B2 plus C1 into C2? And this is nothing but the mod of A bar means what? The magnitude of the A bar vector, which is A1 square plus B1 square plus C1 square into mod of B bar is the magnitude of the second vector. That is in mod of A2 square plus mod of, that is in root of A2 square plus B2 square plus C2 square, and the cosine of the angle between them. On the left hand side we apply this definition, and the right hand side we have applied this. Then what about the cos theta? This cos theta is equals to, this term will be go to the left hand side and it will divide this whole term, and that's why cos theta is equals to A in mod of A1 A2 plus B1 B2 plus C1 C2, and this divided by this whole term, that is in root of A1 square plus B1 square plus C1 square dot in root of A2 square plus B2 square plus C2 square, and this is the angle between the two vectors, between the two lines, between the two vectors A bar and the B bar. Now the condition for the perpendicular lines, when the two lines are perpendicular, the angle between them is a 90, cos 90 is a 0. And what is the condition? Let L1 and L2 be the two perpendicular lines with the direction cosines L1 M1 N1 and L2 M2 N2 respectively. That theta is equals to 90. Cos of theta is equals to cos 90, that's 0. And therefore, the L1 into L2 plus M1 into M2 plus N1 into L2, that's equals to 0. And therefore, conversely, if the L1 into L2 plus M1 into M2 plus N1 into L2 is equals to 0, then it's clear that the two lines are perpendicular to each other. Now the next remark is, A1 B1 C1, A2 B2 C2 are the direction ratios of the perpendicular lines L1 and L2 if and only if A1 A2 plus B1 B2 plus C1 C2, that's equals to 0. Second, if L1 and L2 are the parallel, then what will happen? L1 is equals to plus or minus L2, M1 is equals to plus or minus M2, N1 is equals to plus or minus N2. The positive or the negative sign corresponds to the same or opposite direction of the vectors. Next is if A1 B1 C1 and A2 B2 C2 are the direction ratios of parallel lines L1 and L2, then A1 upon A2 is equals to B1 upon B2 is equals to C1 upon C2. We apply to this condition to solve the problems. Now the next is solve examples. Find A bar dot B bar if mod of A bar is equals to 3, mod of B bar is equals to root 6. The angle between A bar and the B bar is 45 degree. Now the solution. The definition of the dot product. A bar dot B bar is equals to mod of A bar into mod of B bar into cos theta. Mod of A bar is a 3, mod of B bar is a root 6, and cos of 45 is a 1 upon a root 2. If we simplify this, that is a cos 45 is a 1 by root 2. Multiplied here n and d by root 2, then you will get root 2 upon root 2 into root 2, that will become 2. And again next this root 6 into root 2, that will become root of 12 upon 2. Therefore you will get here 3. The 12 can be written as 3 into 4, and the square root of 4 is a 2. Therefore 3 in bracket 2 root 3 upon 2. This 2 get cancelled, and then you will get here, that is a bar dot b bar is equals to 3 root 3. Okay. Now the next example. If a bar is equals to 3i cap plus 4j cap minus 5k cap, and b bar is equals to 3i cap minus 4j cap minus 5k cap, then find a bar dot b bar. Now here a bar is equals to 3i cap plus 4j cap minus 5k cap, and b bar is equals to 3i cap minus 4j cap minus 5k cap. A bar dot b bar, that is I dot I, j dot j, k dot k. 3 into 3, okay, that will, and next is a 4 into minus 4, and the last is a minus 5 into minus 5. 3 into 3 is 9, 4 into minus 4, minus 16, minus 5 into minus 5, that is a plus 25, and 9 minus 16 plus 25, and that's equals to 80. Next, the angle between a bar and the b bar. Let a bar is equals to 3i cap plus 4j cap minus 5k cap, and b bar is equals to 3i cap minus 4j cap minus 5k cap. Mod of a bar is equals to, in root of, this is the 3 square, it means that here is a 9. Okay, I will write here 9. 9 plus 16 plus 25, and the total is a 50. Therefore, mod of a bar is a root of 50. Mod of b bar, that is a 3 square plus 4 square plus 5 square, and then you will get, that is a root of 50. It means that minus 4 bracket square plus minus 5 bracket square, in this way. That is the mod of b bar is equals to root of 50. Both of are the same. Therefore, the angle between the a bar dot b bar is equals to cos theta is equals to a bar dot b bar upon mod of a bar upon mod of b bar. That is 18 upon, we have calculated a bar dot b bar, which is the 18 upon root 50 into root 50, that is a 50, and that's why theta is equals to cos inverse of 18 upon 50. We can simplify also this also. Next is the scalar projection a bar in the direction of the b bar. Here a bar is given 3i cap plus 4j cap minus 5k cap, and b bar is a 3i cap minus 4j cap minus 5k cap. The scalar projection of a bar in the direction of the b bar is a bar dot b bar upon mod of b bar. What is a bar dot b bar? Is 18, and mod of b bar is a root of 50, and if we simplify it, 25 into 2, that is a 5 root 2, 18 upon 5 root 2. Okay. The vector projection of b bar along a bar. Here a bar is equals to 3i cap plus 4j cap minus 5k cap, and b bar is equals to 3i cap minus 4j cap minus 5k cap. The vector projection of b bar along a bar is a bar dot b bar in bracket into a bar upon mod of a bar square. But what is a bar dot b bar? A bar dot b bar is a clear, it is a 18, and mod of a bar square, it's a root 50, and root 50 square is a 50 into a bar. What is the vector a bar? 3i cap plus 4j cap minus 5k cap. Therefore, the vector projection of b bar along a bar is 9 upon 50. If we reduce it, then in bracket 3i cap plus 4j cap minus 5k cap. Next problem, problem number 3. Find the value of a for which the vector 3i cap plus 2j cap plus 9k cap and I cap plus aj cap plus 3k cap are perpendicular and parallel. Let p bar is equals to 3i cap plus 2j cap plus 9k cap, and q bar is equals to I cap plus aj cap plus 3k cap. The two vectors are perpendicular if p cap dot q cap that equals to 0. Therefore, in first bracket 3i cap plus 2j cap plus 9k cap dot in bracket I cap plus aj cap plus 3k cap, and that's equals to 0. I dot I, that is 3 into 1, then you will get here 2 into a, then 9 into 3, that's equals to 0. It is a dot product. Therefore, I dot I, j dot j, j dot k terms will be present there. Now what is here? 1 into 3 is a 3. 9 into 3 is a 27. 27 plus 3, that is a 30. 2 into a, 2a plus 30, and that's equals to 0. And therefore a is equals to minus 15. Next is the parallel. If these two vectors are parallel, then what is that? A1 upon A1 upon A2 is equals to B1 upon B2 is equals to C1 upon C2. That is a 3 upon 1. Next is a 2 upon A, and the last is 9 upon 3. Now here, that is a 2 upon A is equals to 9 upon 3. That is, here you will get, that is the 3A is equals to 2. Therefore, A is equals to 2 upon 3. Next problem. If A bar is equals to I cap plus 2j cap minus 3k cap, and B bar is equals to 3i cap minus j cap plus 2k cap, find the angle between the vectors. That is a 2a bar plus b bar and a bar plus 2b bar. Now first we find out the value of 2a bar plus b bar. That is a 2 in bracket, the value of a bar. That is I cap plus 2j cap minus 3k cap plus b bar. B bar means what? 3i cap minus j cap plus 2k cap. And if we evaluate it, that is a 2 into I. That is a 2i plus 3i, 5i. 4j, and here is a minus j. You will get 3j. Next is a minus 6k, and here is a 2, and then you will get 4k cap, and this is nothing but the n bar. Next is a bar plus 2b bar. A bar I cap plus 2j cap minus 3k cap plus 2 in bracket 3i cap minus j cap plus 2k cap. And if we evaluate it, 2 into 3 is a 6. 6 plus 1 I cap, that is a 7i cap. Here is a 2j minus 2j, that get cancelled. Minus 3k, and here is a 4k, and then you will get only k cap. And this is the n bar vector. M bar dot n bar, that is a 2a bar plus b bar dot a bar plus 2b bar. The value of 2a bar plus b bar is, that is a 5i cap plus 3j cap minus 4k cap. And what about the a bar plus 2b bar? It is a 7i cap plus k cap, and their dot product. That is a j dot. First is a, here is a j, sorry. 5j, 5i cap dot 7i cap. That is a 5 into 7. What about the next? 3. The term of the j is absent in the second vector. Therefore 3 into 0. And what about the last? Minus 4 into coefficient of here k is 1. Minus 4 into 1. That is a 5 into 7, 35. 35 minus 4 into 1. That is a minus 4. 35 into minus 4. Sorry, 35 minus 4. Then you will get 31. Next is their magnitude. Mod of m bar. That is a 5 square plus 3 square plus minus 4 square. 5 square is a 25 plus 9 plus 16. And you will get root of 15. Mod of n bar, and that's equals to root of 7 square plus 0 square plus 1 square. And then again here you will get, that is a root of 50. If the theta is the angle between m bar and n bar, then cos of theta is equals to, because we want to find out the angle between these two, that is a 2a bar plus b bar and the a bar plus 2b bar. Okay, and therefore cos theta is equals to m bar dot n bar upon mod of m bar into mod of n bar. That is, what is the m bar dot n bar? M bar dot n bar is a 31, and their modulus, their magnitude is root 50 into root 50. That is a 50, and that's why cos theta is equals to 31 upon 50, and here theta is equals to cos inverse of 31 upon 50. Now the next problem. If a line makes an angle 90 degrees, 60 degrees, 30 degrees with the positive direction of x, y and the z axis respectively, find its direction cosines. Let direction cosines of the lines be L, M, N. Then L is equals to cos 90. And what is a cos 90? That's a 0. M is equals to cos 60, and cos 60 is 1 upon 2. N is equals to cos 30, and cos 30 is root 3 by 2. And therefore the direction cosines L, M, N are 0, 1 upon 2, root 3 by 2. Now the next problem. Find the vector projection of PQ bar on AB bar, where P, Q, A, B are the points. What are their coordinates? -2, 1, 3, 3, 2, 5. Next is a 4, -3, 5, 7, -5, -1 respectively. Let the position vectors of P, Q, A, B are P bar, Q bar, A bar, B bar respectively. Therefore, P bar is equals to, first is a -2i cap plus j cap plus 3k cap. Q bar is equals to 3i cap plus 2j cap plus 5k cap. A bar is equals to 4i cap minus 3j cap plus 5k cap. And B bar is equals to 7i cap minus 5j cap minus k cap. What about the PQ? PQ is a Q bar minus P bar. What is the Q here? 3i cap plus 2j cap plus 5k cap minus P minus 2i cap plus j cap plus 3k cap. And if we evaluate it, if you open the bracket, that is a 3i cap plus 2i cap, then you will get 5i cap. 2j, and here is a minus j, you will get j cap. 5k cap and minus 3k cap, then you will get 2k cap. This is a PQ bar. What about the AB bar? B bar minus A bar. Now see this here, B bar is a 7i cap minus 5j cap minus k cap. A bar is a 4i cap minus 3j cap plus 5k cap, and their subtraction. 7i cap minus 4i cap, then you will get 3i cap. Minus 5j cap and plus minus and minus, that will become plus here. Minus 5j cap plus 3j cap, then you will get minus 2j cap. And the last is minus k cap, and here is a minus 5k cap. Minus 5 minus 1, minus 6k cap. The vector projection of PQ bar on AB bar, and that is PQ bar dot AB bar upon mod of AB bar bracket square into AB bar, their dot product. What about their dot product? That is a PQ bar dot AB bar. What is the PQ? PQ is a 5i cap plus j cap plus 2k cap, and AB is a 3i cap minus 2j cap minus 6k cap. 5 into 3 plus 1 into minus 2 plus 2 into minus 6 upon mod of AB square, which is the 3 square plus minus 2 square plus minus 6 square into AB bar, which is a 3i cap minus 2j cap minus 6k cap. And therefore, if we evaluate it, then you will get here 5 into 3, 15 minus 2, and here is a minus 12, minus 2 minus 12 minus 14, 15 minus 14, that is 1 here. And 3 square minus 2 square plus minus 6 bracket square, and then here you will get 49. And therefore 1 upon 49 in bracket 3i cap minus 2j cap minus 6k cap, and then again the final is 3 upon 49 I cap minus 2 upon 49 j cap minus 6 upon 49 k cap. Now the next example. Find the value of lambda for which the angle between the vectors A bar, that is a 2 lambda square I cap plus 4 lambda j cap plus k cap, and B bar 7 I cap minus 2j cap plus 7 k cap is the obtuse angle. If the theta is the angle between the A bar and B bar, and then cos theta is equals to A bar dot B bar upon mod of A bar dot mod of B bar. If theta is obtuse, it's a clear that cos of theta is angle is obtuse, then cos of theta is negative, less than 0. Therefore, A bar dot B bar upon mod of A bar into mod of B bar, it's a less than 0. It means that A bar dot B bar, it's a clear, here is a mod quantity, it is always positive. But which will be the negative? A bar dot B bar, that will be the negative. It will be less than 0. Okay. Their mod is always positive. Next is what is the A bar dot B bar? The A bar dot B bar, we will calculate it. The value of A bar is 2 lambda square I cap plus 4 lambda j cap plus k cap into B bar 7 I cap minus 2j cap plus lambda k cap, and that is less than 0. Now their dot product, that is a 2 lambda square I cap into 7 I cap, and then you will get 14 lambda square, 4 lambda j cap and minus 2 j, and then here you will get minus 8 lambda plus k cap and lambda k cap, and here you will get, that is the lambda only. Therefore 14 lambda square minus 8 lambda plus lambda. If you evaluate it, then you will get, that is the 14 lambda square minus 8 lambda plus lambda, then you will get minus 7 lambda, which is less than 0. Again we will simplify it. We will take the common as 7 lambda. If we take the 7 lambda as common, then in bracket you will get 2 lambda minus 1, which is a negative. And that is nothing but here, again if we take the 2 as a common, then in bracket you will get lambda, in bracket lambda minus 1 upon 2, which is less than 0. Again from these we will take the 2 as a common. If we take the 2 common, then in bracket you will get, that is a lambda minus 1 upon 2. Okay. And which will be, what is here? That is here, the value of this, as this is a negative. Okay. This is a negative. When this will be the negative, the value of this lambda must lies between 0 and 1 upon 2. 0 आणि 1 upon 2 मध्ये लॅम्बडाची व्हॅल्यू जर जेव्हा असेल तरच ही क्वांटिटी कशी असेल तर निगेटिव्ह असेल. Now the next is find the direction cosine of the vector 2i cap plus 2j cap minus k cap. Solution. First of all, their magnitude, that is the mod of a bar. Here first we will write the vector. What is that vector? The a bar is equals to 2i cap plus 2j cap minus k cap and their magnitude. That is the mod of a bar is equals to 2 square plus 2 square minus 1 bracket square. That 4 plus 4, 8 plus 1, 9, that is the root of 9 is 3. Mod of a bar is 3. What is the a cap? A cap is equals to, it's a unit vector, vector upon its magnitude. Therefore it is a 2i cap plus 2j cap plus k cap upon 3. And then you will get 2 by 3 I cap, 2 by 3 j cap, and the last is here is a minus sign. I will write here the minus sign. That is a minus 1 by 3 k cap. And therefore the direction cosines of a bar are 2 by 3, 2 by 3 and minus 1 by 3. Now the next problem. Find the direction, find the position vector of a point P such that AB is inclined to x-axis at 45 and to the y-axis at 60 degree and OP is equals to 12 units. I will again repeat this problem. Find the position vector of a point P, means we want to find out that x, y, z, such that AB is inclined to the x-axis at 45 degree and the y-axis is 60 degree. And it's a magnitude, that is the OP is equals to 12 units. We have L is equals to cos of 45 and the cos 45 is 1 by root 2. M is equals to cos 60 and that's equals to 1 upon 2. N is equals to cos gamma. But we know the relation between the direction cosines. That is L square plus M square plus N square is equals to 1. And that's why here the value of L is 1 by root 2, its square is 1 upon 2. Value of M is 1 upon 2, 1 upon 2 square is 1 by 4, M square. And we don't know the N, that is N is cos, N square is cos square gamma, that's equals to 1. 1 by 4 plus 1 upon 2, that will become 3 by 4. Therefore 1 minus 3 by 4, it will become 1 by 4. Therefore cos square gamma is equals to 1 by 4. Take the square root on both sides. What is the cos gamma? That is the cos gamma is equals to plus or minus 1 upon 2. Now the vector r bar is equals to mod of r bar into r cap, mod of r bar into L cap plus mj cap. Next is a nk cap. Again I will repeat here. That is first of all, see this here. R bar is equals to mod of R bar into R cap. That is the mod of R bar. What's its magnitude? Its magnitude is 12, which is given, into L I cap plus mj cap plus nk cap. What is the L? L is equals to 1 by root 2. Substitute the value 1 by root 2 I cap plus m. M is again 1 by 2 j cap. And what about the gamma? N is a plus or minus 1 upon 2 k cap. And therefore the R bar is equals to, if we simplify it, then you will get that is a 12 into 1 by root 2 I cap plus 12 into 1 upon 2 j cap plus or minus 12 into 1 upon 2 k cap. And if we simplify, then R bar is equals to 6 root 2 I cap plus 6 j cap plus or minus 6 k cap, and hence the answer. Next problem. A line makes angle of measure 45 degree, 60 degree with the positive direction of the y and the z axis. Find the angle made by the line with the positive direction of x axis. Let alpha, beta, gamma be the angles made by the line with the positive direction of x, y and the z axis. Here beta is equals to 45 and gamma is equals to 60. Cos beta, cos 45, 1 by root 2, cos gamma, cos 60, 1 upon 2. Cos square alpha plus cos square beta plus cos square gamma is equals to 1. And therefore cos square alpha plus 1 upon 2 plus 1 by 4, that's equals to 1. Here again the 1 by 2 plus 1 by 4, that's a 3 by 4. And 1 minus 3 by 4, it's again 1 by 4. Cos square alpha is equals to 1 by 4. Take the square root on both sides. Then you will get cos of alpha is equals to plus or minus 1 upon 2. As the value of cos alpha is 1 upon 2, then it is a 60 degree. And if you take it's a minus, then it is a 1 upon 2. Because the cos of 120, it goes in second quadrant. In second quadrant, cos is negative. And that's why you are getting this value. At least it's all in 11th standard trigonometry. There are two lines satisfying the given condition. What is that? The angles? Angles is 45, 60 and again 60. And next is a 45, 60 and the 120. Next problem. A line passes through the point 6, minus 7, minus 1. Next is a 2, minus 3, 1. Find the direction ratios and the direction cosines of the line so that the angle alpha is accurate. Let here the first point A, which is the 6, minus 7, minus 1. And B is a 2, minus 3, 1. Be the given points. What about their position vector? That is the A bar is equals to 6 I cap minus 7 j cap minus k cap. And B bar is equals to 2 I cap minus 3 j cap plus k cap. What about the AB bar? B bar minus A bar. That is a 2 minus 6 I cap plus minus 3 minus in bracket minus 7, which is a plus 7 j cap plus 1 minus in bracket minus 1, that will become again plus. That is a 2 minus 6, which is minus 4 I cap, minus 3 plus 7, that is a 4 j cap, 1 plus 1, that is a 2 k cap. The direction ratios of AB bar are minus 4, 4 and 2. Let the direction cosines of AB bar be minus 4k plus 4k and plus 2k. Then minus 4k square bracket square plus 4k square plus 2k square, that's equals to 1. We know that. That is L square plus M square plus N square, that's equals to 1 using that formula. Here we have that is a 16k square plus 16k square plus 4k square, and that's equals to 1. And here 16 plus 16 square plus 16k square plus 4k square, total is a 36k square is equals to 1. And therefore k square is equals to 1 upon 36. Take the square root on both sides and then you will get k is equals to plus or minus 1 by 6. Since the line AB is so directed and the angle alpha which it makes with the x-axis is accurate. That is the cos of alpha is equals to minus 4k, and that's a positive. It means that the value of k must be negative. Then therefore k is equals to minus 1 by 6. We will take the value, not positive. We will take the k as a positive. Because the angle is positive, the value of the cos alpha must be positive. When this will be the positive, then the k must be negative. Okay. Then this negative will become positive. Therefore, we have the two values of the k. One is a plus 1 by 6, another is a minus 1 by 6. If we take 1 by 6, then it will not possible. And if we take minus 1 by 6, then minus and minus, that will become plus here. Minus 4 into minus 1 by 6, that will be plus. And that's why k is equals to minus 1 by 6. And therefore, the direction cosines of AB bar are minus 4, okay, minus 4 into minus 1 by 6, 4 into minus 1 by 6, and 2 into minus 1 by 6. And if we simplify it, and then you will get minus minus, that will become plus. That is a 2 by 3. Again, plus minus, that is a minus 2 by 3. And the last is a minus 1 by 3. These are the direction cosines of the AB bar. Okay. Now the next problem. Prove that the altitudes of a triangle are concurrent. We have proved that in previous exercise, that the medians are the concurrent, angle bisector are the concurrent. And now here we will prove that the altitudes are the concurrent. What is meant by the altitude? That is a perpendicular drawn from this vertex on this AB side, perpendicular drawn from A on BC, and perpendicular drawn from this B on AC. Let ABC be the vertices of a triangle. Let AD, BE, CF be the altitude of the triangle. AD, then the BE, CF, these are the altitude of the triangle. AD is a perpendicular to BC, clear? AD is a perpendicular to BC. B is a perpendicular to AC, B is a perpendicular to AC, and the CF is a perpendicular to AB. Let A bar, B bar, C bar, D bar, E bar, F bar be the position vectors of A, B, C, D, E, F respectively. Let P be the point of intersection of the altitude AD and the B. This is very important. We will consider that is a P is a point of intersection of these two altitudes AD and the B, and then we will prove that P is also intersection with that another altitude, which is the CF. Okay. Let P be the intersection of the altitude AD and the B with the P bar as a position vector, and therefore we are considering that is AP bar is a perpendicular to BC bar. AP bar is a perpendicular to BC bar, and the BP bar is also perpendicular to AC bar. This is our consideration. To show that the altitude AD, B, CF are the concurrent, we want to prove this. It is sufficient to show that altitude CF, this altitude CF passes through the point P. This we want to prove. Same consideration is explained in the 9th standard geometry. Okay, additional properties of the triangle. We will have to prove that CF is a CF and the CP are the collinear. CF and the CP are the collinear vectors. This can be achieved by showing that is a CP is a perpendicular to AB. That is, we want to prove that CF and CP are the collinear. And when it will be the possible, it will be the possible only that CP is a perpendicular to AB. Now, one by one. Now, from 1 we have, there is a from 1 we have, that is AP is a perpendicular to BC. As AP is a perpendicular to BC, BP is a perpendicular to AC. As they are perpendicular, therefore their dot product are 0. That is AP bar dot. Here must be dot product. This is a dot instead of this sign. As AP bar is a perpendicular to BC bar, that is the AP bar dot BC bar is equals to 0. And BP bar dot AC bar, that's equals to 0. But what is the AP bar? AP bar is nothing but the P bar minus A bar dot. And the BC bar is a C bar minus B bar, that's equals to 0. Also BP bar dot AC bar. BP means what? P bar minus B bar in first bracket dot. AC bar means what? C bar minus A bar, and that's equals to 0. And now we will simplify this. What we will simplify? That in bracket P bar minus A bar dot. In second bracket C bar minus B bar. P bar dot C bar. First term. P bar dot B bar, this is the second. Minus A bar dot C bar, this is the third one. And the last one is a minus A bar and this minus, and that will become plus. That is A bar dot A bar, it's a plus A bar dot B bar, and that's equals to 0. This is the expression number 2. Next is a, we'll perform the, simplify this bracket. P bar minus B bar dot in bracket C bar minus A bar. First is a P bar dot C bar. Next is a minus P bar dot A bar. And next is a minus B bar dot C bar. And the last is a minus and minus, that will become plus B bar dot A bar, and that's equals to 0. This is the third one. Now, therefore, the subtracting second from the third. Okay, this is the third one. That is a P bar dot C bar minus P bar dot A bar minus B bar dot C bar plus B bar dot A bar minus in bracket this second now. It is a given in another color. That is a P bar dot C bar in bracket minus P bar dot B bar minus A bar dot C bar plus A bar dot B bar, bracket complete, and that's equals to 0. Now open this bracket. Okay, P bar dot C bar minus P bar dot A bar minus B bar dot C bar plus B bar dot A bar minus, open the bracket, P bar dot C bar, this minus and minus, that will become plus, P bar dot B bar minus and minus, that will again become plus, that is A bar dot C bar, and the last is also minus A bar dot B bar, that's equals to 0. Now see this here, in the red ink all becomes 0. What is that? P bar dot C bar plus and here minus, B bar dot A bar and the A bar dot B bar. Vector product is a commutative. Therefore, A bar dot B bar is equals to B bar dot A bar. Therefore, these 1, 2, 3, 4, these terms get cancelled. What are the remaining terms? The remaining terms are minus P bar dot A bar. Okay. Next is a P bar dot B bar. P bar dot B bar. This is the second one. And the third one is a minus B bar dot C bar. And the last is a bar dot C bar. Rearrangement of the terms. What about the next? We will take here the common as the P bar as a common from these two. And then in bracket you will get P bar in bracket B bar minus A bar. And from these two, we will take the minus C bar as a common. And then in bracket you will get B bar minus A bar. Here B bar minus A bar, B bar minus A bar. Take again B bar minus A bar as a common. Then what are the remaining terms? Which is the P bar minus C bar. But what is the P bar minus C bar? That is nothing but the CP bar. And what is the B bar minus A bar? And that is nothing but the AB bar. And hence we have proved that this CP is a perpendicular to AB, and that's what we want to prove. And hence the proof is approved. Okay. Now we will start the exercise 5.3. Now we'll start the exercise 5.3. Find two unit vectors, each of which is a perpendicular to U bar and the V bar, where U bar is a 2i cap plus j cap minus 2k cap, and the V bar is a I cap plus 2j cap minus 2k cap. Here U bar is equals to 2i cap plus j cap minus 2k cap, and the V bar is a I cap plus 2j cap minus 2k cap. We'll find out their cross product. Okay, that is a ijk, their coefficients 2, 1, minus 2, 1, 2, and again minus 2. Evaluate the determinant. That is I into 1 into minus 2 minus 2, 2 into minus 2 into 2, that is a minus 4, and that minus and minus, that will become plus. This is the first one. Next is the minus, the product of 2 into minus 2, that is a minus 4, plus minus 1 into minus 2, that is a minus and minus will again plus, that is minus 4 plus 2, bracket complete j cap plus, and the last is 2 into 2, 4, minus 1, bracket complete k cap, and then you will get minus 2 plus 4, then you will get 2i cap, minus 4 plus 2, then you will get 2j cap, and then minus and minus, that will become plus, 4 minus 1, then you will get 3k cap, and therefore U bar cross V bar that is equals to 2i cap plus 2j cap plus 3k cap. Their magnitude, mod of u bar cross v bar, and that's equals to in root of 2 square plus 2 square plus 3 square, that is a 4 plus 9, and that is the root of 17. Therefore, mod of u bar cross v bar, that is equals to root of 17. The unit vector perpendicular to both u bar cross v bar, that is equals to plus or minus u bar cross v bar upon their magnitude. That is a mod of u bar cross v bar, that is equals to plus or minus 2i cap plus 2j cap plus 3k cap upon root of 17, and that's equals to plus or minus 2 upon root of 17 I cap plus 2 upon root of 17 I cap plus 2 upon root of 17 j cap plus 3 upon root of 17 k cap, and hence the unit vector perpendicular to both u bar and the v bar, that's equals to plus or minus 2 upon root of 17 I cap plus 2 upon root of 17 j cap plus 3 upon root of 17 k cap. Now the second example. If a bar and the b bar are two vectors perpendicular to each other, then prove that in bracket a bar plus b bar bracket square is equals to in bracket a bar minus b bar bracket square. Now a bar and the b bar are the perpendicular to each other. It means that their dot product is 0. That is a bar dot b bar is equals to b bar dot a bar, that's equals to 0. This is the first expression. Here the LHS, we will find out the LHS. That is in bracket a bar plus b bar bracket square, and that's equals to in bracket a bar plus b bar dot second bracket a bar plus b bar bracket complete. Now simplify this bracket. That is a bar will multiply this in bracket a bar plus b bar plus b bar will multiply in bracket a bar plus b bar. What is the a bar dot a bar? Then here is a bar dot a bar, then a bar dot b bar, next is the b bar dot a bar, b bar dot b bar, a bar dot a bar, that is a bar dot a bar, here is a mod of a bar square, that will be the a square, and that is nothing but the mod of a square. A bar dot a bar is a square, and that is nothing but the mod of a square. And similarly b bar dot a bar dot b bar, that will become 0 as we have given. These two a bar and b bar are perpendicular to each other. Next is the b bar dot b bar. B bar dot b bar is a b square, that is a mod of b bar bracket square, mod square. This is our LHS. Now the RHS. What is the RHS? A bar minus b bar bracket square. In bracket a bar minus b bar bracket square is equals to in first bracket a bar minus b bar dot a bar minus b bar, and again simplify this. That is a bar dot in bracket a bar minus b bar, and the next is a minus b bar dot in bracket a bar minus b bar. Now here a bar dot a bar, next is a minus a bar dot b bar, next is a minus b bar dot a bar, and the last is b bar dot b bar. That will minus and minus, that will become plus. The first is a bar dot a bar, that will become mod of a bar square. And the what about that a bar dot b bar minus b bar dot a bar? And here the sign is plus. Minus a bar dot b bar plus b bar dot a bar. Vector product, the dot product is a commutative, therefore that will become 0. And lastly we will get b bar dot b bar, that is a mod of b bar square. And therefore this is the RHS. What is the RHS? Mod of a bar square plus mod of b bar square. And therefore LHS is equals to RHS, and hence in bracket a bar plus b bar bracket square is equals to a bar in bracket a bar minus b bar bracket square. When this will happen? That is that these two vectors are perpendicular to each other. Now the next problem. Find the value of C so that for all real x, the vectors xi cap minus 6j cap plus 3k cap and xi cap plus 2j cap plus 2cxk cap makes an obtuse angle. Now first we will denote, that is a bar is equals to xi cap minus 6j cap plus 3k b cap. Sorry, I will again repeat here. A bar is equals to xi cap minus 6j cap plus 3k cap. Another vector b bar, that is equals to xi cap plus 2j cap plus 2cxk cap. Now we'll find out their dot product. A bar dot B bar. That is in bracket xc I cap minus 6j cap plus 3k cap dot in next bracket xi I cap plus 2j cap plus 2c xk cap. Their dot product xc into x. Next is a minus 6 into 2 and the last is a 3 into 2cx, and you will get that is a cx square minus 12 6cx. Therefore here you will get cx square plus 6cx minus 12 if the angle between a bar and the b bar is obtuse. It means that a bar dot b bar must be negative, and therefore cx square plus 6cx minus 12, and that is negative, less than 0. If we change the sign, then this less than will become greater than. That is a minus cx square minus 6cx plus 12 is a greater than 0. For the above expression to be the positive, first c minus c must be greater than 0, and that will become plus here. Next is their discriminant, that the d must be negative. Therefore here we'll write as the minus c is the greater than 0, it means that c is a less than 0, and their discriminant means what? B square minus 4ac. What's the b here? Minus 6c bracket square minus 4 a and c. A is a minus c and b is a 12, which is less than 0. And if we simplify this, this is very important. Minus 6c bracket square means what? 36c square, and this minus and minus, that will become plus 48c, which is less than 0. Take 12c as a common and then bracket 3c plus 4, which is less than 0, that is a negative. We know that the c is a negative, that is the c is less than 0. But as 12c will be again negative, that is here c is a negative, but this must be positive then, that is a 3c plus 4 must be positive. As c is a negative, 3c plus 4 must be positive. It means that 3c plus 4 greater than 0. And if we simplify this, then you will get subtract 4 on both sides, divide 3 on both sides. Then you will get c is a greater than minus 4 by 3. As a c is a greater than minus 4 by 3, we have consideration. This is our consideration, that the c must be negative. It means that the value of c lies between minus 4 by 3 and the 0. That is, c belongs to minus 4 by 3 and 0, or c is a negative. This is the value. This is also answer. In the textbook, c is a negative, this is answer, but I will again modify here. That is, the c belongs to the interval minus 4 by 3 and the 0, or c lies between minus 4 by 3 and the 0. Now the next problem. Show that the sum of the lengths of projection pi cap plus qj cap plus rk cap on the coordinate axis, where p is equals to 2, q is equals to 3, r is equals to 4, is 9. Here a bar is equals to pi cap plus qj cap plus rk cap. The projection of a on x-axis is a bar dot I cap upon mod of I cap. That is a pi cap plus qj cap, here is a j, qj cap, plus rk cap dot I cap. I cap dot I cap, that will become 1. And here you will get p is equals to 2. Projection of a on y-axis is again a bar dot j cap. And again here you will get, that is a pi cap. Next is a qj cap. I will change here again here j to all the expression. Middle term is j. That is a qj cap plus rk cap dot j cap. And again their multiplication. J cap j is 1 and other remaining will be 0. And here you will get q is equals to 3. What about the last? The projection of a on the x-axis by using the projection formula on the, on the z-axis. Again I will repeat here. Projection of a on the z-axis is a bar dot k cap upon mod of k cap and their multiplication. Then you will get k cap dot k cap, that is r only, and the remaining will be 0. Therefore r is equals to 4, and their sum of their projection, That is a 2 plus 3 plus 4, and that's equals to 9. Now the next problem. Suppose that all sides of quadrilateral are equal in length and opposite sides are parallel. Use the vector method to show that the diagonals are perpendicular. Now the solution. Let ABCD be a quadrilateral in which we have given that the all sides are equal. That's the mod of AB bar, mod of BC bar, mod of CD bar is equals to mod of DA bar. And next is the opposite sides are parallel. Means what? AD is parallel to DC, and AB is a parallel to DC and AD is a parallel to BC. Okay. And therefore, as they are all of them have the same magnitude, and the AB is a parallel to DC, it means that the AB bar is equals to DC bar, and also AD is a parallel to BC. Again, AD bar is equals to BC bar. Okay. Now here, AC bar is equals to, see this here, AC bar. AC bar means what? AB bar plus BC bar. And what about the BD bar? BD bar is nothing but BA bar plus AD bar. But what is the BA bar? BA bar is nothing but the minus AB bar. And the AD bar is nothing but the BC bar. And therefore we can write here that is a BD bar is equals to BC bar minus AB bar. And what about the AC bar? AC bar is the AB bar plus BC bar. We want to show that their diagonals are perpendicular. Means what? We want to find out their dot product of AC bar and the BD bar. And that dot product that equals to 0. And therefore here AC bar dot BD bar, that is in first bracket the value of AC bar is AB bar plus BC bar. And next is also the value of BD bar in terms of BC and AB, it is a BC minus AB bar. Now their multiplication, AB bar in bracket BC bar minus AB bar plus BC bar in bracket BC bar minus AB bar. Therefore AB bar dot BC bar, next is a minus AB bar dot AB bar, next is a BC bar dot BC bar, and the last is minus BC bar dot AB bar. Now here we know that is a AB bar dot BC bar is equals to BC bar dot AB bar. That is a dot product is a commutative. And hence we have that is a AB bar dot AB bar, that is a mod of AB bar square. And what about the next? BC bar dot BC bar, that is a mod of BC bar square. And the remaining term that will become 0. Which will become 0? That is the AB bar dot BC bar and the BC bar and BC bar dot AB bar. These two terms will become 0. And here you will get that is a mod of BC bar minus mod of AB bar. And now all the sides are equal in magnitude, and therefore mod of BC bar minus mod of AB bar, and that's equals to 0. It means that the diagonals are perpendicular to each other. Since AC bar and the BD bar, these are the non-zero vectors. Therefore AC bar is a perpendicular to BD bar, and hence the diagonals are perpendicular. Okay. Therefore we can prove that that is all the sides of a quadrilateral are equal in the length and opposite sides are parallel. Then we have to use the vector method to show that the diagonals are perpendicular. Next problem, determine whether A bar, B bar are orthogonal, parallel or neither. Now here A bar is equals to minus 9i cap plus 6j cap plus 15k cap. B bar is equals to 6i cap minus 4j cap minus 10k cap. Now here A bar is equals to minus 9i cap plus 6j cap plus 15k cap. Take 3 as a common, minus 3 as common. Then in bracket you will get minus 3 in bracket 3i cap minus 2j cap minus 5k cap. And multiplied here n and d, numerator and the denominator, by 2. Then you will get 6i cap minus 4j cap minus 10k cap. Now see this again here. That is a 6i cap minus 4j cap minus 10k cap. upon 2, that is we are multiplying n and d by 2. But this is nothing but the b bar. Therefore, a bar is equals to minus 3 by 2 b bar. That is the a bar is a non-zero scalar multiple of the b bar, and that's why a bar is a parallel to b bar. Next is a bar is equals to 2i cap plus 3j cap minus k cap, and b bar is equals to 5i cap minus 2j cap plus 4k cap. What is a bar dot b bar? That is in bracket 2i cap plus 3j cap minus k cap dot. In second bracket 2i cap minus 2j cap plus 4k cap, and their dot product 2 into 5 plus 3 into minus 2 plus minus 1 into 4. What is the 2 into 5? 10 minus 6 minus 4, and overall that is the sum is 0. Since a bar and the b bar are the non-zero vectors and their dot product is 0, therefore a is orthogonal to b bar. A bar is orthogonal to b bar means what is perpendicular to b bar, that vector. Next is a bar is equals to minus 3 by 2 I cap plus 1 by 2 j cap plus 1 by 3 k cap, and b bar is a 5 I cap plus 4 j cap plus 3 k cap. What about the a bar dot b bar? In first bracket minus 3 by 2 I cap plus 1 by 2 j cap plus 1 by 3 k cap dot. In bracket 5 I cap plus 4 j cap plus 3 k cap, and their dot product minus 3 by 5 into 5 plus 1 upon 2 into 4 plus 1 by 3 into 3. What about their dot product? That is a 5 get cancelled, you will get minus 3. And 1 upon 2 into 4, then you will get 2. 1 by 3 into 3, you will get 1. That is 2 plus 1, 3 plus 3 minus 3, that becomes 0. Therefore, a bar dot b bar is equals to 0. A is orthogonal to, a bar is orthogonal to b bar. Next is a bar is equals to 4i cap minus j cap plus 6k cap, and the b bar is equals to 5i cap minus 2j cap plus 4k cap, and their dot product. A bar dot b bar is equals to 4i cap minus 2j cap plus 6k cap dot in bracket 5i cap minus 2j cap plus 4k cap. Again their dot product 4 into 5, that is a 20. Next is a minus 1 into minus 2, that is a plus 2. And the last is 6 into 4, that is a 24. And their sum is not equals to 0, that is a 46 not equals to 0. Therefore, a bar is not orthogonal to the b bar. It's clear that a bar is a scalar multiple of the b bar, and therefore a bar is not a parallel to b bar. Therefore, a is neither parallel nor orthogonal. Okay. Now the next problem. Find the angle P of the triangle whose vertices are P, 0, minus 1, minus 2, Q, 3, 1, 4, R, 5, 7, 1. The position vectors P bar, Q bar, R bar. The points of the points P, 0, minus 1, minus 2, Q, 3, 1, 4, R, 5, 7, 1. These are the position vectors. That is P bar, which is the minus j cap minus 2k cap. Next is a Q bar is equals to 3i cap plus j cap plus 4k cap, and the R bar is equals to 5i cap plus 7j cap plus k cap. PQ bar. PQ bar means what? Q bar minus P bar. That is a 3i cap plus j cap plus 4k cap minus P bar minus in bracket minus j minus 2k cap. If you simplify, then you will get 3i cap plus j and here plus j, then you will get 2j, 4k plus 2k, then you will get 6j cap. What about the PR bar? R bar minus P bar. What is the R bar? R bar is a 5i cap plus 7j cap plus k cap minus in bracket minus j minus 2k. If you open the bracket, then you will get. What about the I cap? I cap is a 5i cap is as it is. 7j cap, this minus and minus will become plus, that will become 8j cap. K cap and plus 2k cap, that will become 3k cap. Now their dot product, that is a PQ bar dot PR bar. Their product, that is a 3 into 5, 2 into 8 and 6 into 3. And overall, you will get 15 plus 16 plus 18, that is equals to 49. Their magnitude, that is the magnitude. To find out the magnitude, mod of PQ bar is equals to in root of, see this here PQ bar, in root of 3 square plus 2 square plus 6 square. And the PR bar is a 5 square plus 8 square plus 3 square. And here you will get 9 plus 4 plus 36, that is the root of 49, that's 7. And the PR is a 5 square plus 8 square plus 3 square, that is a 25 plus 64 plus 9, that is the root of 98. And it can be written as 49 into 2, that is a 7 root 2. Using the formula for the angle between the vectors, we want to find out the angle P. That is, we must require the two vectors. Which are the two vectors? PQ and the PR. And therefore cos of P is equals to PQ bar dot PR bar upon their magnitudes. That is the mod of PQ bar in. Again I will repeat here. That is the cos of P is equals to, see this here, PQ bar dot PR bar upon their magnitudes, mod of PQ bar into mod of PR bar. That is their dot product, which was the 49. 49 upon mod of PQ is a 7 and mod of PR bar is a 7 root 2. 7 into 7, 49. 49 upon 49 get cancelled, 1 upon root 2. That is the cos of 1 by root 2 means what? Cos of 45. And hence P is equals to 45. Now the next problem. If P bar, Q bar, R bar are the unit vectors, then find P bar dot Q bar and P bar dot R bar. Let the triangle be denoted by ABC, where AB bar is equals to P bar, AC bar is equals to Q bar, and BC bar is equals to R bar. Since P bar, Q bar, R bar are the unit vectors, therefore length of AB is equals to length of BC is equals to length of CA. That's equals to 1. The triangle is equilateral, and that's why angle A is equals to angle B is equals to angle C is equals to 60. First we find P bar dot Q bar using the formula for the angle between the vectors. That's the cos of A. Cos of A is equals to P bar dot Q bar upon their magnitudes. Therefore cos 60 is equals to P bar dot Q bar upon 1 into 1. And that's why cos 60 is 1 upon 2. Therefore P bar dot Q bar is equals to 1 upon 2. This is first one. Second, P bar dot R bar. Again using the formula P bar dot R bar. P bar dot R bar. That is the angle between them is B. Therefore cos of B is equals to P bar dot, here is a P bar dot R bar upon mod of P bar into mod of R bar. And here we get, that is the cos of 60. Cos 60 is a 1 upon 2. Therefore P bar dot R bar is equals to 1 upon 2. Okay. Now the next problem. Prove by vector method the angle subtended on a semicircle is a right angle. That is the measure of angle APB is equals to 90 degree. Let segment AB be a diameter of a circle. AB is the diameter of a circle with center C. And P be any point on the circle other than A and B. Then angle APB subtend on a semicircle. Let AC bar is equals to CB bar. AC bar is equals to CB bar. And that's equals to 8. And also CP bar, that is equals to R bar. Okay. Next is a mod of A bar is equals to mod of R bar. Now AP bar is equals to, see this here, AP bar is equals to AC bar plus CP bar. AC bar plus CP bar. But what is the AC bar? AC bar is A bar and the CP bar is R bar. And therefore we can write it as, that is R bar plus A bar. Okay. Next is a BP bar. See this here, BP bar. Now what is a BP bar? BP bar means what? BC bar plus CP bar. And BC bar means what? Minus CB bar plus CP bar. And what about the CB bar? CB bar is a minus A bar plus R bar. That is a CB bar. CB bar is a minus A bar plus R bar, and therefore their dot product. That is, as these two are the perpendicular, means what? AP bar plus BP bar, their dot product. We will find out their values, AP bar and the BP bar. AP bar is a R bar plus A bar, and the BP bar is a R bar minus A bar, and their dot product, R bar dot R bar, that is the mod of R bar square, R bar dot A bar dot, okay, and the A bar dot R bar dot, and the last is a minus A bar dot A bar. Now these two will get cancelled, R bar dot A bar plus minus R bar dot A bar plus A bar dot R bar. Dot product is a commutative, and here you are getting R bar dot R bar means what? Mod of R bar bracket square minus mod of A bar bracket square. But R and A, these two are equal. That is the mod of R bar is equals to mod of A bar, and that's equals to they are equal, and therefore their subtraction is a 0. Therefore AP bar dot BP bar, and that's equals to 0. Means what? The dot product of the two vectors is a 0. It means that AP is a perpendicular to BP, and hence the angle APB is a right angle, and hence the angle subtended on a semicircle is a right angle. Now the question number 10. If a vector has the direction angles 45, 60, find the third direction angle. That here alpha is equals to 45, beta is equals to 60. We have to find the gamma. Cos square alpha plus cos square beta plus cos square gamma, that's equals to 1. Alpha is 45, therefore cos square 45 plus cos square 60 plus cos square gamma, that's equals to 1. Cos of 45, 1 by root 2 bracket square, plus cos 60 is 1 upon 2, and it's a square, plus cos square gamma. Here is a cos square gamma, and that's equals to 1. And 1 by 2, 1 upon root 2 square means what? 1 upon 2. 1 by 2 bracket square means what? 1 by 4, and overall you will get cos square gamma is equals to 1 minus 1 upon 2 minus 1 by 4. 1 minus 1 by 2 minus 1 by 4, minus 1 by 2 minus 1 by 4, that will become 3 by 4. 1 minus 3 by 4 means what? 1 by 4. Take the square root on both sides, and then you will get cos of gamma is equals to plus or minus 1 upon 2. And now we will find out its values. That is, once you will take the cos of gamma is a plus 1 upon 2, and another cos of gamma is minus 1 upon 2. But cos of gamma as 1 upon 2 means what? Angle is pi by 3. And here now we will find out by using the allied angles. Cos of gamma is equals to minus 1 by 2 means what? Cos of pi by 3. And by allied angle, cos of gamma is equals to minus cos of pi by 3. That is nothing but the cos of pi minus pi by 3, that is equals to cos of 2 pi by 3. Therefore cos of gamma is equals to cos of 2 pi by 3. And here we have the two values of the gamma. That is a pi by 3, and the gamma is a 2 pi by 3. And hence the third direction angle is a pi by 3 and the 2 pi by 3. Now the next problem. If a line makes angle 90, 135 degree, 45 degree with the x, y and the z axis respectively, then find its direction cosines. Let L, M, N be the direction cosines of the line. Then L is equals to cos alpha, M is equals to cos beta, N is equals to cos gamma. Therefore alpha is equals to 90, beta is equals to 135, and gamma is 45. We know that as L is equals to 90, that is alpha is 90, therefore L is equals to cos of alpha means what? Cos 90. Cos 90 is 0. What about the next? M is equals to cos of beta. But what is a beta? Beta is 135. And this 135 can be written as cos of 180 minus 45. It is in second quadrant. That is a minus cos of 45. And that is a minus 1 by root 2. And the last is N is equals to cos of 45. That is 1 by root 2. And hence the direction cosines of that line is 0, minus 1 by root 2 and 1 by root 2. Next problem. If a line has the direction ratios 4, minus 12, 18, then find the direction cosines. The direction ratios of the lines are A is equals to 4, B is equals to minus 12, C is equals to 18. Let L, M, N be the direction cosines of the line. Therefore, L is equals to A upon in root of A square plus B square plus C square. That is equals to, the value of A is 4. 4 upon 4 square plus minus 12 square plus 18 square. That is a 4 upon 16 plus 144. 18 square means what? 324. And their sum. That is a 16 plus 144 plus 324. Their sum is a 484. And their square root is a 22. Therefore, it is a 4 upon 22. That is a 2 upon 11. And this is the L. Next is a M is equals to B upon in root of A square plus B square plus C square. Substitute the value of B, which is the minus 12. Again, the same thing. That is a minus 12 upon 22. And then you will get, that is a minus 6 upon 11. This is the value of M. And the last C is, N is a C upon in root of A square plus B square plus C square. That is 18 upon, you will get, it is a 22. And here you will get 9 upon 11. This is the value of N. And here is the direction cosines of the line are 2 upon 11, minus 6 upon 11 and the 9 upon 11. Next problem. The direction ratios of AB bar are minus 2, 2, 1. If A is a 4, 1, 5 and the length of AB is a 6 unit, find B. The direction ratios of AB bar are minus 2, 2, 1. The direction cosines of AB bar are L is equals to, we can find out it, minus 2 upon in root of minus 2 square plus 2 square plus 1 square. And what is here? This total is a 9, root of 9 is a 3. And therefore L is equals to minus 2 by 3. Similarly, M is equals to 2 upon 3. N is equals to 1 upon 3. These are the values of L, M, N. The coordinates of the point which are at a distance D unit from the point x1, y1, z1 are given by, and this is the formula that you have to remember. x1 plus or minus LD, y1 plus or minus MD, and z1 plus or minus MD. Substitute the value of x1, y1, z1. x1 is a 4 and the y1 is 1 and the z1 is a 5. These are the coordinates. What about the L? L is equals to minus 2 by 3, M is equals to 2 by 3 and the N is equals to 1 upon 3. If we substitute the values of x1, L, D and all these in this formula, then here you will get 4 plus or minus minus 2 by 3 into 6. Next is a 1 plus or minus 2 by 3 into 6. Next is a 5 plus or minus 1 by 3 into 6. And if we simplify, here is a, if we simplify minus 2 by 3 into 6, then you will get minus 4. 2 by 3 into 6, then you will get 4. And here 1 by 3 into 6, you will get 2. Therefore, 4 plus or minus minus 4. 1 plus or minus 4. 5 plus or minus 2. And we will get the 2 points. First, we take this plus and then in bracket it has a minus sign. And therefore, you will get the 4 minus 4. Next is a 1 plus 4. And the last is 5 plus 2. Next point is a, if we take minus sign, then 4 minus in bracket minus 4. That will become plus. That is 4 plus 4. 1 minus 4. And the last is a 5 minus 2. And hence the points are 4 minus 4 is 0. 1 plus 4 is a 5. 5 plus 2 is a 7. 4 plus 4, that is a 8. 1 minus 4, that is a minus 3. And the 5 minus 2, that is a 3. And in this way, these are the coordinate of the point B. Now the last problem. This problem also in the last year textbook. Find the angle between the lines whose direction cosines are L, M, N. Satisfy the equations. That is a 5L plus M plus 3N is equals to 0. And 5Mn minus 2NL plus 6LM is equals to 0. Now this is the first equation. What is that? 5L plus M plus 3N is equals to 0. What about the second equation? 5Mn minus 2LN plus 6ln, that's equals to 0. Now from the first expression, it can be written as m is equals to minus in bracket 5l plus 3n. Put this value of m in the expression number 2 and then you will get, that is a minus 5 in bracket 5l plus 3n bracket complete n, minus 2nl minus 6l in bracket 5l plus 3n, that's equals to 0. And if we simplify this, then you will get minus 25nl minus 15n square, that is this is the 3n into n, and 3n square into again minus 5 minus 15n square, minus 2ln, and the next is a minus 6l into 5l minus 30l square, and the last is a minus 6l into plus 3n, then you will get minus 18ln, and that's equals to 0. And if you simplify it, then you will get minus 13l square minus 25ln and minus 18nl and minus 2. Overall you will get 45nl, and the last is a minus 15n square. And again if we simplify it, divide by it with the 15, then you will get 12 square plus 3ln plus n square, that's equals to 0. And this is the quadratic equation. That is a 12 square, 3ln can be written as 2ln plus n square, that's equals to 0. Take 12 as common, then in bracket you will get l plus n. Take n as common, in bracket you will get n plus l plus n, that's equals to 0. And the factors are, that is in first bracket l plus n, in second bracket 2l plus n, that's equals to 0. Therefore l plus n is equals to 0 or 2l plus n is equals to 0, and hence l is equals to minus n or n is equals to minus 2l. Now we have calculated the value of m. M is equals to minus in bracket 5l plus 3n, and here if we substitute l is equals to minus n, that is l is equals to minus n, then you will get m is equals to minus in bracket minus 5n. If we substitute l is equals to minus n, that is a minus 5n, and here is a plus 3n, you will get minus 2n, and that minus and minus will become plus 2n. M is equals to 2n, and here we are getting that L is equals to minus n, M is equals to 2n, and if we equate it, then you will get here, that is divide this by 2. Okay, what is here? L is equals to minus n, and what about here? M is equals to 2n, means what? N is equals to, you are getting m upon 2. If we make this as a positive, that is n is equals to minus l, and here n is equals to m upon 2, and therefore you are getting minus l is equals to m by 2 is equals to n. Okay, we are equating with the n, the values of n. N will be as it is, but n is equals to what? M by 2. N is equals to what? Minus l. This is very important. L is equals to minus n, m is equals to n by 2 from this expression. Okay, m is equals to 2n means what? N is equals to m by 2, and we will equate it considering that is the m is equals to m by 2 and n is equals to minus l. Yes. Now minus l is equals to m by 2 is equals to n means what? L upon minus 1, m upon 2, n upon 1. The direction ratios of the first line are a1 is minus 1, b1 is 2, c1 is 1. Now next is n is equals to minus 12. If we take n is equals to minus 12, see this, n is equals to minus 12. Then what about the m? Again the value of m from here starting. M is equals to minus 5l plus 3n. If we substitute the value of n, and then you will get, that is a minus in bracket 5l minus 6n. If we substitute here the value of n is equals to minus 12, and it is a 3n, 2 into 3, it will become minus 6, minus 5l minus 6n. Okay, sorry, 5l minus 6l, that will become minus l, and that minus and minus that will become plus. Okay, therefore here you will get n is equals to l. Now here n is equals to l, first is n is equals to l, and therefore L is equals to M is equals to N upon minus 2. M and L both are equal, therefore we have L is equals to M. And what about here L? L is equals to minus N by 2, and this is replaced by N. L, M, N. N is replaced by N upon minus 2. And therefore we have here L upon 1, M upon 1, and that's equals to N upon minus 2. Okay, and here we have A2 is equals to 1, B2 is equals to 1, and C2 is equals to minus 2. Let theta be the angle between the lines. That is the cos of theta is equals to A1 A2 plus B1 B2 plus C1 C2 upon in root of A1 square plus B1 square plus C1 square into in root of A2 square plus B2 square plus C2 square. Substitute the value of A1 A2. Here A1 is minus 1 and A2 is 1. Minus 1 into 1. What about the B1? B1 is 2 and the B2 is 1. That is a 2 into 1. And what about the last? C1 is 1 and the C2 is minus 2. Upon in root of again minus 1 square plus 2 square plus 1 square into in root of 1 square plus 1 square plus minus 2 bracket square. And their multiplication minus 1 plus 2 minus 2. And overall you will get minus 1. Root 6 into root 6. You will get 6. And mod of minus 1 upon 6 means what? 1 by 6. That is a cos theta is equals to 1 by 6, and that's why theta is equals to cos inverse of 1 by 6. And in this way, we have completed the exercise 5.3. Now we'll see in the next video. Till then, goodbye.